Yeah, here the first topic is IP as the IoT network layer. See, just now I told you IP is a internet protocol for the network layer. Already you know this one, right? So here we are treating this IP usually as a layer here. Okay. Of course, it is a protocol. Now onwards, we are just wherever I talk about IP means you just think about that. Sir is talking about a network layer. Okay. So because already I have discussed physical layer and MAC layer. Now let us go to next layer, that is network layer, in which the protocol is IP. Okay. And in this particular first topic of this module, I am discussing IP as a IoT network layer. So what I am going to discuss here is, it is nothing but in this entire module, what all the things we are going to see. That is a brief summary of this module. Okay. So what all the topics I am going to discuss, these all things we will see here. And actually, it is better to see what I am going to learn in this module in the early stage only. So that's why I want to explain these all topics first to you briefly, because if you open the question papers, sometimes they will ask this also. So explain IP as a IoT network layer. So you have to explain something about this module, what all the things you have studied in this module, and what all the topics you have studied, right? So because of that only, they may ask anything, for 4 marks or for 8 marks also sometimes. So that's why I thought that let me to explain what all the things we are going to study here. Okay, in this first topic, just I explain the what all the things we will study in this module. Okay, so here in the previous module, we had one topic there, that was connecting the smart objects. If you remember, before IoT access technologies, we have studied their communication criteria. Communication criteria is nothing but there we have studied some features and characteristics of IoT networks. There we have seen some range, frequency, and so many other things we have seen there. There's like topology, right? So many other things we have studied. So before that, there was one small topic was there, that is connecting smart objects. It means that how to connect the smart objects in IoT network. So in that only we dive into the topic. It means we went in depth in the topic, that was a communication criteria. Okay. After communication criteria, we went once again deep to learn about IoT access technologies. So these communication criteria as well as IoT access technologies, you can together treat it as a connecting the smart objects, because here we all studied what all the things we need to connect the smart objects, right? So here in previous topic, in previous module, there was one module topic was there, that is connecting smart objects. So there we have learned many important considerations, so many important considerations, as just now I told you. It may be communication criteria, or it may be IoT access technologies. So these all considerations we have studied. Why we have studied? To create or to develop a IoT network. And apart from this creation of IoT network or developing IoT network, we also studied, we also focused on some most commonly used protocols to make that communication success. Okay, which are very, very essential. So most common protocols we have studied there. And in that one, if you take the best example and most important protocol, Zigbee and Zigbee IP. Okay, just for example, I am telling you. So like this, so many standardization, standard protocols we have studied to connect these smart objects. So why we have studied these all things? So clearly I told you here, to access the network. Which network? IoT network. And to communicate with the network. Network means what? Group of or collection of devices which are connected, interconnected, right? So to access these smart objects, it means to communicate with these smart objects, we have studied these all things. Okay, we have considered these all considerations. And that topic, that connecting smart object topic, mainly focused on connectivity at the layer 1. Layer 1 usually we treat it as a physical layer, and connectivity at the layer 1 as well as in the layer 2. Layer 2 is nothing but MAC layer. Okay. So these two layers we have already studied that. So here, now in this module, what we are going to do is here, we are going to move to the next layer, that is third layer. That third layer is nothing but here network layer. Okay, so in this module we will go to the protocol stack, so and extend that conversation to the network layer. It means we will go to the, we will go and we will discuss the next layer, that is a network layer connectivity. And usually this network layer is commonly here, I call it as a layer 3. So remember, layer 1 is nothing but physical layer, layer 2 is nothing but MAC layer, and layer 3 is nothing but network layer. Okay, and if you go back little, okay, if you go back little backward, and if you observe the topic core IoT functional stack in a previous module or first module. Okay, so in not in second module, in first module, that last topic, last but one topic, that is you have studied core IoT functional stack. Okay, so there if you observe in the figure 17 of my notes, okay, so there if you consider that IoT core functional stack, so here in this module what we are going to, it means that sir, why you are telling these all things, where exactly we are standing today. Okay, because in first module we studied something, in second module we studied something, okay, in third module what we are going to study, right? So it means that where we are standing today, so that I want to make you sure. In module 3 we are going to cover the network transport layer. Network transport layer is a sub layer. Sub layer where it is, if you observe the figure number 17 in a module number 1 of my notes, then you will get this topic core IoT functional stack. So there in this core IoT functional stack, if you observe, we have seen a diagram, that is figure 17, that is a simplified IoT architecture. Okay, and after that you will get one more figure, that is a expanded IoT architecture. In that expanded IoT architecture, you can observe there in the core IoT functional stack, that is a left side stack. So you can observe there is one layer is there, that is a network transport layer. Okay, so we are going to cover this network transport layer in this module 3. Okay, so next is if you go again somewhat behind that figure 17, okay, that topic. So if you go somewhat behind or backward in that module 1 again, so in figure 11 you will get one more layer which is called as a connectivity layer. Okay, and in figure 11 what you are going to see, you are going to see one M2M architecture. Okay, so this one M2M architecture is visible in figure 11 of my notes in my module number 1, and in that figure you will get one layer that is called as connectivity layer of IoT world forum architecture also in figure 12. In figure 11 you get this architecture, one M2M architecture, and in figure 12 you will get IoT WF architecture, that is IoT world forum architecture in figure 12 in the module number 1, right? So there is one layer is there, connectivity layer. So connectivity layer, you just observe the words here. So connectivity is related to networking, right? So because of that only, so what exactly we are studying here, briefly already you studied physical layer and MAC layer of each and every access technologies, right? So now we have to move to next layer, that is network layer, that is nothing but related to communication, connectivity, interaction, right? So this type of words you will keep on looking here. And the module 3 is made up of these following topics. The first topic will be here, the business case for IP. The business case for IP is nothing but, you just remember, whenever we start a business, what all the things, what all the terms we use there. So usually we think about the investment and how much profit I get and how much loss I may get, right? So these all points we will keep in our mind, right? Here also this topic, why we titled like this, business case for IP, it means that we are going to see some pros and cons of this IP here. It means we are going to see some advantages and disadvantages of this IP. Because of that only we call it as business case for IP. That's all its meaning is, that's all. So what are the advantages I have for this IP, and what are the disadvantages I may get. because of use of this IP. These all things we are going to see in this business case for IP. Okay, so then we are going to see two very important concepts in this business case for IP. Those concepts are called as adaptation and adaptation. There is a lot of differences there in between adaptation and adaptation. See, adopt meaning already generally if you see adopt, we adopt something, right? So we adopt means what? We will completely take over of it. It means we will completely accept it. Okay, so that is nothing but adaptation. It means there is no any problem to you, so you will completely accept it, you will completely access it, you will completely take on it, you will completely follow it, right? So many general meanings are there. So in other hand, there is one more term we are going to see here, that is adaptation. Adaptation, adoption, adaptation, adaptation. Okay, so what it is? Adaptation, it means that it is a, there is some adjustment will be there. If you are not completely accepting that, then you are you are continuing to use of something by making some adjustments, by making some compromises. That is called as adaptation. Okay, if you are not ready to accept it, if you are not ready to achieve it, then at least you have yourself have to adjust with it. Okay, if you cannot change something, you have to adjust with it, right? So if you don't, if you cannot change your friend, you have to adjust with him. That's all. That is the final solution for it. Okay, to stay or to live with him. Okay, so these are the two concepts, adoptions and adaptations. So it means that you can adopt the IP, whatever the advantages and disadvantages it has. Okay, if you don't want to accept its disadvantages, then you have to make some compromises or some adjustments, and you have to continue to use that IP. So that is coming under adaptation. Okay, so that is called as versioning. It means you just use its subversion, or you use it in other form, or you make adjustment accordingly and you use it. Okay, so either you use a readily available IP with its whatever the advantages and disadvantages may be, or else you make adjustment according to. Okay, so here the next topic will be need for optimization. Optimization is nothing but so improvisation or updation. Okay, why we will keep on working on optimization of IP? Okay, so why we have to optimize it? Because day by day there are so many new technologies are coming, right? So to cope up with those technologies, to deal with those technologies, we should keep on improvising this IP to support those technologies, to be compatible with those new technologies. Are you understanding what I am telling, guys? Okay, so that is the need for this optimization. Optimization of what? Optimization of IP. Okay, so in this topic we will dive into this challenges of constrained nodes. Already you know what is constrained node. These are end nodes or end devices which will support or which will deal or which will cope with the specific applications. In previous module already I have given the definition of constrained nodes and constrained devices and constrained networks also we have discussed. Okay, so here we are going to see some challenges of these constrained nodes and constrained devices whenever we use this IP. Okay, so it means that we are going to see some challenges of these constrained nodes or devices of IoT network whenever we use or implement a IP. And also here in this part or in this topic, we will see a migration or a transition or a transformation from IP4 to IPv4 to IPv6. Because why we stopped using IPv4 and why we started to use IPv6? Just keep it in your mind. The beautiful advantage of IPv6 is nothing but why we started to use this IPv6 instead of IPv4. The limitation of IPv4 is whatever the IP addresses we can create, whatever the IPv4 IP addresses we can farm, they are exhausted now. Now, because of increase in the number of devices, we cannot allocate a individual and unique IP address to each and every device with IPv4. Okay, so because all IP addresses with which with IPv4 we were using to create it, right? So these all IP addresses, whatever we created with IPv4, whatever we wanted to create with IPv4, those all IP addresses exhausted now. There is a limitation is there. So the some particular number of IP addresses only we can create with this IPv4. Okay, so that we can individually uniquely identify a device. Since the number of devices are keep on increasing nowadays, so IPv4 we cannot use now to create a IP address or to allocate a IP address to that particular devices. So now we shifted to IPv6. Then you may ask me, sir, what about IPv5? IPv5 was also there, but it was not in this world for a long term usage. So immediately we started to use IPv6. So these IPv4 and IPv6 are only playing the important role here. Okay, with IPv6 you can create as many as IP addresses as possible, and you can allocate those IP addresses to the devices. In fact, in computer networks textbook, the author beautifully explained it. Every sand grain also we can address or identify with a particular IP address. That many number of IP addresses we can form with the help of IPv6. Are you understanding? That is the importance of IPv6 and how it is going to affect our IoT network also. We are going to see in this need for optimization. The next topic will be optimizing IP for IoT. Optimizing IP. You see, just now I told you optimization of what? Optimization of IP. So here, how exactly we can optimize this IP for this IoT, we will see in the third module. And in this third module, we are going to explore the common protocols. So most commonly used protocols and other technologies in the IoT networks, which are using the IP protocol, okay, or IP layer or network layer. Okay, so these protocols will be what all the protocols we are going to see here. That is nothing but 6LOWPAN. In the previous class, I already told why it is 6. It is another form of IPv6. Okay, it is a continuation form of IPv6, particularly for low power wireless power area network, right? So IPv6 low power wireless personal area network. And one more protocol what we are going to study is a 6TiSCH, and one more protocol is RPL. Already I many times I used this protocol RPL. What is the use of RPL? Just remember, this is a routing protocol. Remember, this is a routing protocol to route the packets in your network. This protocol will be used, and it is the most commonly used popular protocol RPL for routing purpose. Okay, and these three protocols we will study here. And then next topic will be profiles and compliances. So profiles and compliances here, what we are going to see here, it is going to provide us a summary of some of these most important organizations of significant organizations or companies. Okay, and some significant standard bodies also we are going to study here, so which are helping this IP in a connectivity and in a IoT. So these are all topics we are going to study here, and these not only these four topics there. Apart from these four, again some other topics will be there, because just now what I told you is these are the topics which are in only one chapter. Okay, next chapter is also continued later. Okay, so that we will discuss later, don't worry about now. Okay, then let me to go to the first topic, that is important topic, business case for IP. Already I told you, here we are going to see advantages and disadvantages of IP. Okay, so data flow from one thing to another thing in the IoT. IoT means what? Internet of Things, right? So many devices are there, sensors, actuators, and smart objects. Okay, so this data will be moving from one device to another device in IoT network, obviously, right? So this data, who is consuming? It means who is taking this data and who is using that data, who is collecting that data, who is storing that data, and who is controlling that data, and who is monitoring that data, and where exactly we are storing this data. So remember, this data will be stored, okay, this data will be stored either in the cloud, okay, or else in the physical locations. Remember, these data will be either we can store in a cloud or else in a physical locations, okay. Though these physical locations may be distributed or centralized. It means distributed means what here? Throughout the entire world, these all physical servers, physical machines are distributed or they are situated, or else centralized. It means there will be only one server in the central level, and from that central level only all clients may be accessing the or requesting the data. So this data is stored in this centralized location, okay. So in these cloud and locations, whatever I am discussing, so these cloud will be, obviously it will be virtual, and these locations what I told you just now, definitely I used one word here, that is a physical here, right? So inside this cloud and locations, so where exactly we are storing the data. So remember, inside this cloud or else these physical locations, there are some data center servers, okay. So data center servers are there inside these clouds. Inside these clouds, these data centers and data center servers are there. No, inside these data centers only we are going to store the data which is generated by these sensors and these all smart things, whatever they are present in our IoT network. And this data movement is there, no, in between one sensor to another sensor. That data flow or data movement will be consumed or controlled or monitored by these data servers. It means indirectly I am telling that this data is stored in these servers, and these servers are located in this cloud or any physical locations which are decentralized or centralized. Distributed means what? Decentralized, okay. And dedicated applications are there, which are lightweight applications, which are small softwares or small applications, okay. So these applications are going to run or execute on a virtual or a traditional operating system. Virtual means what? Again, the machines which are running on cloud with some operating systems. So we will call them as virtualized operating system, or else some physical operating systems or traditional operating systems on physical machine, or else we can run these applications on a network edge platforms like fog computing. So there are three options are there in front of us to run the applications. Either we can run them on virtual operating system or physical operating system. It means physical machine, okay. So physical traditional operating system, or else we can run these applications on network edge platforms or fog computing, okay. These lightweight applications now onwards start to communicate with each other, as well as they communicate with the data servers. So why they want to communicate with the data servers? Of course, I am talking about applications, right? So which are using some sensors. So those sensors are transmitting the data, they are generating the data, and that data is transferring to these servers, right? Data servers. Or else some applications are needed some data which is already stored in these data servers. So like this, the data communication is going on between the applications and data centers. Are you understanding? To or from the data centers. Okay. So therefore, these system solutions which are combining this physical layer and data link layer, they will use one architectural approach. It means they will use one architecture with some common layers which are independent from these lower layers. I already told you. So what are those lower layers? In that lower layers, completely we are focusing on connectivity. It may be physical layer, it may be MAC layer, and it may be network layer, okay. then these are completely independent from this lower layer and upper layer. It means they are not dependent on them. So upper layer means which layers? Application layers. Already I told you in protocol stack. Application support layer, application profile layer. These layers already we have seen in previous module, right? So some common layers are there which are independent of these layers, lower layers and upper layers. Okay, so in this architecture I am telling. Okay, so this is how and why this IP protocol suite is started and playing its important role in our architecture in early 1990s. See, in 1990s onwards we started to use this IP protocol suite. Okay, so then IP was not only the preferred in the IT markets but also for the OT environment. See, in first module I already clearly mentioned you the difference between IT and OT. What is the role of IT field and IT team, and what is the role of OT team? Okay, and this IoT is making these both teams to work together. Then only we are calling it as a IoT. Okay, earlier before IoT, these two teams were working separately. There was no any proper coordination and communication between these two teams. Now IoT bring these two teams on a same platform or a single platform, then we are calling it as a IoT, right? So here, in fact, this IP is not only made for IT teams. This IP can be used in OT teams also. Okay. So then let me to go to the key and very important advantages of internet protocol here. So one main difference between this uh, IT and OT is a lifetime of the technologies or lifetime of the products. So whatever the products which are producing by it may be OT team or it may be IT team, what is the lifetime of that product? Okay, if a product if a product which is produced by IT is living a long life, maybe OT product is not supporting it. Okay, or if a OT team is producing some product and which is having a long life, okay, but IT is not allowing it or it is not supporting it. So this type of coordination is not present in between IT and OT. So if we achieve this coordination between IT and OT, and if let them to work together on a same platform, then we can take advantage of our IoT. Then it means that we can make a best use of IoT. Okay, so here the main difference between these two teams or technologies, it may be information technology or operational technologies, main point is here lifetime. So they are not supporting each other in in terms of lifetime of products and lifetime of technology. Okay, so entire industry being a software engineers, you should, of course, you should consider software companies only. Okay, IT industry. Okay, so entire industry workflow will be there. Every organization, every company has its own workflow means what here? So in which flow you are going to produce the products. So it is nothing but your software development life cycle only. So you will analyze the problem and you will design, then you will plan, you will code it, and you will build it, and you will test it. If anything happens there, you will again send the code back to the developers, and then if test is successful, then you will deploy it or you will implement it, and you will validate it and you will verify it. Like this, they have their own workflow, right? In industry, whatever the workflow is there, that workflow will make a mandatory of a smooth, okay, smooth, what it is, smooth running of this workflow. Okay, and incremental steps that evolve, it means continuously there should be a improvement in the workflow. So we should not stuck in only first stage only. And then with the proper operations itself, see here which it is, operations. So I am talking about what here? Operational technology. So with operations itself being the most time factor and mission critical factor for that organization. So just listen. this beautiful word, it is the most important factor. What is that important factor? Time critical factor and mission critical factor for that organization. It means that, so that organization has its own goal. That aim of that organization is that it has to deliver the product as faster as possible. Are you understand? Because it is an advantage for that organizations only. So how many number of projects it completes and it submit it to the clients. So in a short period of time, if it is able to submit that product to the client, then more number of projects it can do, and more number of products it can produce, and it can submit to the various number of clients. So then it is a profit for that organization only, right? So instead of producing a one product in one 6 months, okay, so within 6 months you are able to produce six products. So this will be the aim of organization, every organization, of course. Okay, so because of this, they will mandate a smooth workflow and incremental steps in that workflow. Okay, so here, what is important here? Time is very important for them. So in a short period of time, they want to deploy, or they want to deliver more number of products. Okay, so one way or one method to guarantee this multi-year lifetimes. Multi-year lifetimes means what? Already told you here, lifetime is a difference between IT and OT. Okay, so to support this multi-year lifetime, so it is you what method we are using is, we are going to define, or we are going to use a layered architecture. See, this is the solution. We should use a layered architecture if you want long life of your products or technologies. That is a multi-year lifetime. The solution is layered architecture we have to use. Okay, so here layered architecture is already present there, just we have to use it. Like which architecture? 30-year-old IP architecture is there. It means that now we are in 2021. It means if you go back 30 years back, it means this architecture was from 1991 itself. So this architecture is already 30-year-old now. Okay, so this IP architecture we have to use. Which architecture? IP architecture, which is a 30-year-old. Okay, which is a layered architecture. Why we should use? It is a solution for multi-year lifetime. It means that if you produce the products which live long life, okay, which last long life. If you use the technologies, or if you develop a technology which last long life, right? So for this, the solution is you use a layered architecture, which is a IP architecture, which is a 30-year-old architecture. Okay, so IP has ability to integrate means combine these small and large evolutions or improvements, updates. Okay, IP is very much flexible. For every update it will keep on improving, every updation it will be keep on updating with the previous versions. So here it will take the improvements of these all small improvements or updates, as well as a major updates also. Okay, so at the same time, it is also it has ability to maintain its operations for large number of devices and large number of users. So what it does, it maintain operations. It maintains the operations for large number of devices and large number of users. It means that, just understand, IP supports large number of devices and large number of users. That's all. Because of that only nowadays 3 billion together internet users are there. 3 billion, more than 3 billion internet users are there, because IP is supporting these all 3 billion users. Okay, so now the key advantages of IP suite is a IP suite or IP protocol in the Internet of Things or IoT is a first advantage is open and standard based. Some 6 advantages I am going to discuss. Remember, open and standard based is nothing but open based, closed based. Just remember one thing, closed based means it is not free to access. Okay, it is called as a proprietary. Closed is nothing but another word, you can use it as proprietary. In fact, in our softwares also, open source software and closed source softwares are there, right? So here we are studying not softwares, here we are studying about network solutions here, or IoT. Okay, so closed networking solutions means some technologies are not free to access, we have to pay for them, that is closed or proprietary. Okay, so these vendors or first manufacturers will manufacture the technologies or products, then vendors will sell those technologies, or vendors will sell those products. Okay, so here vendors know very well what is the demand in the market. Okay, what is the demand in the market, what the users expect. Based on that, vendors will inform to the manufacturers. Based on that, manufacturers will supply the need or demand. Okay, so here vendors of these OT technology, I am only talking about OT technology, optimized. Who optimized? Vendors of OT optimized the communications. It means they improvised this communication. How? Through these closed networking solutions. It means by developing these closed or proprietary networking solutions, they improvised these communications. Communication between whom? Communication between one smart object to another smart object in IoT network. Okay, and also communication between the applications and cloud or data centers. Okay, so IoT creates a new paradigm, or it creates a new era. What it does, so earlier before IoT I was talking about closed or proprietary networking solution. Then when we started to use IoT, that is Internet of Things, it completely changed this era or this method. It means huge number of devices started to adding to the IoT network, right? So huge number of sensors started to be used, and huge number of actuators, smart objects, so many other devices, n number of devices started to be connected in IoT network. So because of these n number of devices, if one sensor is inactive, or if one sensor is passive, another sensor can work in the place of that sensor, but work will not be held up. Are you understanding what I am telling? Because of a huge number of sensors or devices in IoT network, if one sensor failed, the remaining sensors will be keep on working, and the process will not be held. Okay, so because of that only, here very important and beautiful word I have used, interchangeability and interoperability possibility is there. Interchangeability means instead of using one particular sensor, if it fails, the other sensors will start to work. They will be keep on working, of course. And interoperability is there, and there is a proper coordination and communication is there between these all sensors, actuators, and other devices, smart objects. And security is also there, and management of these all devices is there, right? So these all things, because of these all things, IoT made it as a open networking solution. Remember, open solution. It means that anybody can now onwards use this solution. It is open for anybody. It means that earlier we need to pay for it, now no need to pay for it. Are you understanding? Okay, so Internet of Things create a new era in which devices, applications, and users can leverage. It means that they can take advantage of this large set of devices. It means particularly some person wants some data. Okay, if that sensor is not providing him a data, another sensor will provide, because there is no only one sensor, many sensors are there. Okay, if one application wants to access some data, and if a actuator or sensor is not providing that necessary data, then another sensor will provide it. So because of these all n number of devices, applications, and users, nowadays users are using n number of devices, applications, and devices of IoT. So they all take advantage of this huge number, large number, okay, number of devices and functionalities, and they guarantee that interchangeability and interoperability, and also they guarantee the security and management. So because of these all advantages, This calls or it uses implementation, validation, and deployment of what type of solutions? Open solutions or open based solutions or standard based solutions. Earlier it was closed, now it is opened. This is a one advantage of IoT IP. Okay, now versatile is nothing but great diversity. That is nothing but how widely you are using IP. So here the large number of access technologies are available to us, what we have studied in the previous module in the last topic. So they will provide us the connectivity of these things. Of course, in previous module we focused on connectivity, right? So because of that only we studied communication criteria topic and also IoT access technologies. So these all IoT access technologies, n number of IoT access technologies are there. Very few we have studied in last module. Okay, so these all IoT access technologies are providing us a connectivity of things. They support us the connectivity of these things, and some additional protocols and technologies are also exist. Okay, so just we studied Zigbee and Zigbee IP like that. Still, so many other protocols are there. So these all additional protocols and technologies are existing, and how they are helping us? They are helping us to transport the IoT data through these backhaul links. That's it. So these backhaul links may be physical links or they may be wireless links. Okay, these additional protocol and technologies are used here to transport the IoT data, particularly which data? IoT data through these links and in the data center. Of course, data will be stored in the data center, right? Then even though physical layer and data link layer are there, like Ethernet, Wi-Fi and cellular, which are already widely adopted, but the history of data communication, if you observe, okay, history of data communication, if you observe, it shows us clearly or it tells us clearly that no wired or no wireless technology fits all the situations. Okay, so some wired technology and some wireless technology, they will not fit in all situations or all deployment criteria. Even though we have these powerful technologies like Ethernet, Wi-Fi and cellular, they have already widely adopted because, but in some situations, these all Wi-Fi, Ethernet and cellular will not support us in some situations, in some cases. Okay, so also communication technologies evolve more faster than expected. It means that communication technologies are day by day evolving. One new technology is coming. Okay, so they evolve more faster than expected lifetime of IoT solution, OT solutions. Expected lifetime of OT solution is at least we are expecting that 10 to 20 years of OT solution, but within 3 or 4 years, for every 3 or 4 years, one new communication technology is taking birth or inventing or occurring in the market. Okay, so the layered IP architecture is well equipped to deal with these all compatible or to deal with or to be compatible with any type of physical and data link layers. That is nothing but the layered IP architecture. This is a solution, just remember. Okay, this is the advantage of IP. Okay, to overcome these problems, because everywhere physical layer and data link layer will not work. Some other layer we have to use. That layer is nothing but network layer with a layered architecture, that is IP architecture. Okay, so then this is going to make or to deal with a suitable long-term investment, because various protocols have these layers means what? Physical layer and data link layer can be used in a deployment now, but after some times there is no requirement of changes. Right now we may need to make some changes in a deployment, but over time, after some time, there will be no any requirement of changes to the whole solution architecture and data flow. Once the architecture is set up, then initially it may require some changes. After that, it will not require any change. Okay, so if you use IP architecture, which is a layered architecture. Okay, I think within 2 minutes this meeting will end. In next class I continue. The next class I take at I think 1 o'clock. I think I take UID class today. Okay. Uh, Now, whatever the timing is there in your timetable, you just see the UID class. Today I take that UID class. I continue in the UID class. Okay. Now you can leave the meeting. I continue in next class.